Prototyping is a crucial part of the product development process, but traditionally, it has been a bottleneck due to the high costs and long lead times. Producing prototypes that look and work like the final product historically requires the same traditional manufacturing processes used to create the final part. But these methods require costly tooling and lengthy setup. With rapid prototyping tools, such as Formlabs 3D printers, anyone can turn ideas into realistic proofs of concept and advance these concepts to high-fidelity prototypes that actually look and work like final products. Best of all, 3D printed prototypes are cost-effective, enabling teams to create dozens of affordable prototypes with a quick turnaround. In this video, we'll walk you through the fundamentals of rapid prototyping, its applications, and how 3D printing can help you develop prototypes quickly and cost-effectively. What is rapid prototyping? Rapid prototyping is the group of techniques used to quickly fabricate a physical part from a three-dimensional design. With rapid prototyping, engineers and designers can create a better final product, iterating several times between digital designs and physical prototypes with a quick and cost-effective workflow. Here's an example of a rapid prototyping workflow with 3D printing. A typical model takes a 24-hour design cycle. First, design your project in CAD during work hours. Next, 3D print the prototype parts overnight. In the morning, clean, measure, test, create assemblies, and collect feedback on your design. Then, tweak your design and repeat the process. Rapid prototyping applications. Rapid prototyping applications include proof of concept models to help product designers validate ideas, looks like prototypes to evaluate the design, works like prototypes to accurately represent the finished product and validate the functionality, and engineering prototypes and pre-production validation parts to simulate the final product and validate manufacturability. Rapid prototyping allows designers to go beyond virtual visualization, making it faster and easier to understand the look and feel of the design and compare concepts side by side. Black Diamond, maker of outdoor sports and mountaineering equipment, has incorporated 3D printing into their design workflow for years. Recently, their team brought full-size prototyping in-house with a large format SLA 3D printer, the Form 3L, and they managed to cut prototyping costs by up to 85% and lead time from a week to 1 day. Rapid prototyping also allows engineers to thoroughly validate prototypes, reducing the risks of usability and manufacturability issues before moving into production. Smart brewing equipment manufacturer Play-Doh developed an optically clear airlock for real-time monitoring of beer during fermentation. Creating 6 iterations per day, Play-Doh had done hundreds of different prototypes in total. That was only feasible as they had a Formlabs 3D printer in-house. By eliminating outsourcing, in-house rapid prototyping improves communication with peers and clients, quickly turning actionable user feedback into new iterations. This is essential for creators to produce market-leading products. 3D printing for rapid prototyping. SLA and SLS are two of the most popular 3D printing solutions for rapid prototyping. Stereolithography, or SLA 3D printers, use a laser to cure liquid resin into hardened plastic parts with high resolution and accuracy, clear details, and smooth surface finish. SLA is a great option for highly detailed prototypes requiring tight tolerances and smooth surfaces, such as concept models and functional parts. SLA printing also offers the widest range of materials. Use draft resin to print early concept models faster than with any other process, standard resins for highly detailed or transparent models, and engineering resins for tough, durable, heat-resistant, flexible, or extremely stiff functional prototypes. SLS 3D printers use a high-powered laser to fuse small particles of polymer powder. The unfused powder supports the part during printing and eliminates the need for dedicated support structures. This makes SLS ideal for complex geometries, including interior features, undercuts, thin walls, and negative features. Parts produced with SLS printing have excellent mechanical characteristics, with strength resembling that of injection molded parts. The combination of low cost per part, high productivity, and established materials makes SLS a popular choice among engineers for functional prototyping. Bring your products to the next level with in-house 3D printing, powered by Formlabs.